So, okay, welcome back again. So, in the previous example we have seen that this example delta f steady state is equal to 0.1162 hertz, right. Now, next example, suppose two generators rated, this is a typical example, rated your 250 megawatt and 400 megawatt, they are operating in parallel. So, droop characteristic of the governors are, now you know the governor droop characteristic meaning of 4% or 2% whatsoever and 6% respectively. How would a load that of 650 megawatt be shared between them, right, and what will be the system frequency? Assuming nominal system frequency is 60 hertz, it is given and no governing action. So, if you see the rated capacity of the one generator is 250, another is 400. So, total is 650 megawatt, right, and load also you have to match the 650 megawatt. So, if their governors characteristic like this, right, droop characteristic 4% and 6%, we have to find out that which generator is generating how much power, right. So, from this you can from your intuition you can make it something that this is 250 and this is 400, but droop characteristics are given. So, naturally there is strong possibility one generator will be overloaded because of because total load is 650 megawatt, right. So, how we will do this? So, let load on generator 1 say x megawatt, and then therefore, load on generator 2 will be 650 minus x megawatt, because total load to be supplied by these two generators are your what you call is 650 megawatt, right. So, generator 2 will be 650 minus x megawatt. Now, say due to this reduction in frequency is delta f, right. Therefore, we can write for the first generator whose droop characteristic is your 4%. So, delta f by x is equal to 4% of the nominal frequency is given 50 hertz. So, it is 4% of 60, right, divided by its rated capacity. This is one equation. Similarly, for second generator delta f upon 650 minus x, right, is equal to, that is 6% of the nominal frequency divided by its rated capacity, right. Therefore, you solve these two equation for x. So, if you solve these two equation for x, you will get that x is equal to it is what you call 314.52 megawatt, right. So, this one your, so generator 1 it is 314.52 megawatt and generator 2 it is 335.48 megawatt, but generator 1 that rated capacity is 250 megawatt. So, if generator 1 generates your 314.52 megawatt, that means the generator 1 is much overloaded, I mean it is more than 20% overloaded, right. So, that means your and second generator is okay within that limit, because generator rating is 400 megawatt. So, it is generating 335.48 megawatt as per their your what you call the droop characteristic. So, it is highly loaded, right. So, I will suggest that when you will solve this problem, you consider another one, say when droop characteristic for generator 1, say for generator 1 you take 2%, right. Suppose it is 2% and for generator 2 it is for 6%, you solve this one, right. Similarly, this is you will get one set of solution for your two generators. Similarly, another case you take G1 is equal to say 6% and G2 is equal to 2%, right, and you solve this one and see what is happening, right. So, but that means your the generator 1 is heavily loaded. So, if we know the x, then you substitute the value of x either of this equation and solve for delta f. So, delta f will be 3.019 hertz, the frequency it will deviate like this. Therefore, system operating frequency will be, because 60 hertz is nominal frequency, it will be 60 minus 3.019. So, 56.981 hertz, right. So, this is the answer, but one thing again that generator 1 is heavily loaded, it is more than 20%, right. So, that is why I give you other two problem. Now, another example, that example 4, say a 200 MVA generator, right, 200 MVA generator operates on full load at a frequency of 60 hertz, right. The load is suddenly reduced to 20 megawatt. Load reduction means that your frequency will increase or speed will increase, right, but you will never lose synchronism. Due to time lag in governor system, the steam valve begins to close after 0.22 second, right. So, we have to determine the change in frequency that occurs in this time, given that the inertia of the generator 10 kilowatt second per kVA. This is your what we call basically kilowatt kVA is actually it is your dimensionless quantity. So, H is equal to actually 10 second, right. If given H is equal to 10 second also, and you can take like this, that H is equal to, if it is given 10 your kilowatt upon kVA this thing second. So, you can write according to the looking into the system, you can write that is your 10 kilowatt second per kVA, right. This way one can your what you call, this way it is given. So, actually kilowatt by kVA is a dimensionless quantity. So, basically it is a second inertia constant, right. So, when you will solve this problem, that store kinetic energy, the rating your what you call, the rating of the generator is 200 MVA, right. So, that means it is 200 into your 1000 kVA, right. So, that inertia store kinetic energy is basically H into the rated capacity. So, it is 10 kilo your what you call, it is 10 kilowatt second per kVA, that is the H inertia, into PR, that means this one into 200 into 1000, right. That is what has been written here, 10 into 200 into 1000 kVA. So, kVA cancel actually, finally actually it becomes your 10 into 200, this is actually kVA, to mega MVA has been converted to kVA, it is kilowatt second, right, is equal to 2 into 10 to the power 6 kilowatt second, right. Next is, so excess power input to generator before the steam valve begins to close 20 megawatt, right. So, excess energy input to the rotating parts in 0.22 second, because if you look into the problem, that the load is suddenly reduced to 20 megawatt due to time lag in governor system, the steam valve begins to close after 0.22 second, right. Therefore, that your excess energy input to rotating parts, right, in 0.22 second will be 20 megawatt converted to kilowatt, right. So, 20 megawatt multiplied by 1000 into 0.22. So, that is 4400 kilowatt second, right. And now stored kinetic energy is proportional to the square of the frequency or speed, we know square of the frequency. So, frequency at the end of 0.22 second directly you can make it, right, using this relationship, that at the actually stored kinetic energy is proportional to the square of the speed. That means your this is 60 into, initially it was 2 into 10 to the power 6, then plus this your total is 4400 divided by 2 into 10 to the power 6 to the power half, right. So, that will give you 60.066 hertz, because kinetic energy is proportional to the square of the speed, right. So, that means load has stripped, that 20 megawatt load has stripped. So, frequency actually will increase, that is why it is more than 60 hertz. So, see that 60.066 hertz, that means its deviation actually 0.066 hertz, right, this one, right. So, this problem, these 2-3 problems we have seen. Now, we will go to the your next one. So, AGC of 2 area interconnected power system. So, here it is suppose area 1, it is a power system, area 2 interconnected by tie line. I told you tie line means 3-phase transmission line, and it is not shown here. Suppose you put to bus bar here, voltage here is V1 angle delta 1 0, and this voltage V2 angle delta 2 0, right. And your tie, it has your tie line has resistance and reactance, but we will neglect the resistance and we will consider only the reactance, the x 1 2, this is bus bar, this is 1 and this is 2, right. So, and power flowing from assuming a direction 1 to 2, that is p tie 1 2, that is the scheduled power flowing from area 1 to area 2. So, suppose in the system there is some load disturbance. So, but we will assume we have discussed before that if real power load changes, that it affects mainly the system frequency or speed, hence the your voltage angle, right, but leaves the bus voltage magnitudes actually unaffected. Therefore, if we assume some load disturbance is there for which your this delta 1 delta 2 change, right, but V 1 V 2 will remain constant, right. V 1 and V 2 both voltage magnitude will remain constant due to some change in the real power. So, if it is so, then we can write the tie line power flow rather than your p tie 1 2, I will make it suffix 0, that initially p tie 1 2 superscript 0. So, p tie 1 to 0 is V 1 V 2 upon x 1 2 sin delta 1 0 minus delta 2 0, right. This you know also, and x 1 2 is the reactance of the tie line, and V 1 V 2 will remain constant, right. So, delta 1 0 and delta 2 0 are the power angles, right. Now, for incremental changes in delta 1 and delta 2, the incremental tie line power can be expressed as this is we are writing that delta p tie 1 to pu like this, but this one I will derive for you, right. So, this p tie 1 2 actually 0 superscript I have given. So, it is given now due to some just hold on, due to some your disturbance that your things have changed. Suppose this is my area 1, right, and this is my area 2. Say we make A 1 and this is A 2, right, and this is your bus 1 and this is your bus 2, and voltage here is V 1 angle delta 1 0 and this is V 2 angle delta 2 0, right, area 1 and this is my area 2, right, and power is flowing through this is delta p tie initially scheduled power 1 to 0 and reactance of this one is j x 1 2, right. So, we from this we not delta p this thing p tie 1 to 0. So, we can write that your p tie 1 to 0 is equal to V 1 V 2 by x sin of delta 1 0 minus delta 2 0, this is x 1 2, right. So, this we know. Therefore, suppose due to some load is changing all these things all the time. So, suppose due to some load disturbance, real power load disturbance, now this delta p tie 1 to 0 will change, right, because of this voltage magnitude will remain constant, but delta 1 0 and delta 2 0 also it will change. So, for example, suppose then p tie 1 to 0 it changes to your say p tie 1 to 0 plus delta p tie 1 2, right. So, similarly, now delta 1 0 will be it will be changed to delta 1 0 plus delta 1, right. Similarly, delta 2 0 it will be changing to delta 2 0 plus delta 2 due to this. So, all these changes you incorporate here. If you if you incorporate here, so I am now I need lot of space. So, I am now deleting this one, but I will rewrite on it. So, what you can write now that therefore, p tie 1 to 0 plus delta p tie 1 2 is equal to V 1 V 2 by x 1 2 sin of your delta 1 0 change to delta 1 0 plus delta 1 and delta 2 0 change to delta 0 minus your plus delta 2. So, it will be it will be minus delta delta 2, right. That means this one will be is equal to V 1 V 2 upon x 1 2, then sine of your delta 1 0 minus delta 2 0 plus delta delta 1 minus delta delta 2, right. Now, this one you expand, that sin A cos B plus cos A sin B. So, if you do so, it will be V 1 V 2 upon x 1 2, right. So, sin A, then cos B, right, then plus cos A your sin B, right. So, this way you can write. Now, question is that delta delta term is very small, right. Therefore, we can write delta delta 1 minus delta, as it is very small, it is approximately 0. Therefore, cos of delta delta 1 minus delta delta 2, it is basically 1. Similarly, as delta delta 1 minus delta delta 2 is very small, that means sine of delta delta 1 minus approximately is equal to delta delta 1 minus delta delta 2. You know, if theta is very small, sin theta is equal to theta. So, therefore, sine of delta delta 1 minus delta delta 2 will be delta delta 1 minus delta delta 2, right. Therefore, this equation, that means we can write like this, that p tie 1 to 0 plus delta p tie 1 2 is equal to, right. So, this term is 1. Therefore, it is V 1 V 2 upon x 1 2 sine of delta 1 0 minus delta 2 0, right. Then this term actually plus that cosine your plus V 1 V 2 upon x 1 2 cosine of delta 1 0 minus delta 2 0 into your delta delta 1 minus delta delta 2, right. Therefore, we can write, I am just clearing this. So, we can write p tie 1 to 0 plus delta p tie 1 2, right, is equal to, actually the first term will be of that expression p tie 1 to 0 plus V 1 V 2 upon x 1 2 cosine of delta 1 0 minus delta 2 0 into delta delta 1 minus delta delta 2, right. So, this is actually your what you call that that your expression. Now, left, if you look into this, then this one will be cancelled, right. Therefore, your delta p tie 1 2 is equal to V 1 V 2 upon x 1 2 cosine of delta 1 0 minus delta 2 0 into delta delta 1 minus delta delta 2, right. This term we define, this term it is 1 to 2. So, this is equal to, it is, we can write just hold on, we will convert it to per unit, right. So, this term actually we call synchronizing coefficient. Why it is called synchronizing coefficient, that is a question to you. I mean, you should give the answer in the forum. So, now if the rated capacity of area 1 is say PR1, so if you divide both sides by PR1, say rated capacity of area 1 PR1, if you divide on both sides, then delta P tie 1 2 divided by PR1 is equal to V 1 V 2 x 1 2 PR1, right, cosine delta 1 0 minus delta 2 0 into delta delta 1 minus delta delta 2, right. That means, this is now in per unit, and this synchronizing coefficient also it will be per unit, because V 1 V 2 upon x 1 2, right. So, basically it is expression of power, I mean your its unit, your what you call unit is power. So, this is also your what you call in per unit, Therefore, we can write that delta p tie 1 2 it is in per unit is equal to T 1 2, of course it is in per unit, right, into delta delta 1 minus delta delta 2, right. So, after that we will not use per unit again and again, but it is understandable. Therefore, in general we can write that delta p tie 1 2. So, we are not writing per unit again and again, understandable, T 1 2 that your delta delta 1 minus delta delta 2, right, where T 1 2 is equal to V 1 V 2 cosine delta 1 0 minus delta 2 0 divided by x 1 2 into P r 1, right. This is called synchronizing, this term is called synchronizing coefficient. So, now this is your T 1 2. Similarly, your if we write delta p tie, if you write delta p tie 2 1, I mean 1 to 2, now 2 to 1, if you write it will be V 1 V 2 cosine delta 2 0 minus delta 1. In fact, cosine minus theta is equal to cosine theta. So, cosine delta 2 0 minus delta 1 0 or cosine delta 1 0 minus delta 2 0, it is same, right. So, divided by, in this case your what you call, it will be P r 2, then your x 1 2, then this side it will be delta delta 2 minus delta delta 1, because 2 to 1, that is why delta delta 2 minus delta delta 1. So, this is actually T to 1, right. That means everything is in per unit, this is also in per unit. Therefore, delta p tie 2 1 is equal to T 2 1, right, into your delta delta 2 minus delta delta 1, right. So, this is actually your what you call this relationship of 1 2 or 2 1, right. So, but everything is in per unit, this is also per unit, this is also per unit. Now, that, so first one, when we write delta p tie 1 2 say expression, when we write it is T 1 2 delta delta 1 minus delta delta 2, the first one. So, we know in general we know, right, generally delta is equal to say omega t, right. Therefore, delta dot is equal to omega, that means, or you can write delta delta dot is equal to delta omega, or delta delta dot is equal to 2 pi into delta f, right. Therefore, delta delta is equal to 2 pi integral of delta f dt, this is the general thing, right. That means that delta p tie 1 2 is equal to T 1 2, then it is, then delta delta 1 will write, that means delta delta 1 we will write that in the bracket I am putting 2 pi integral of delta f 1 dt, right, minus 2 pi integral of delta f 2 dt, right. That means, delta p tie 1 2 is equal to your 2 is equal to 2 pi T 1 2, then integral of delta f 1 dt minus integral of delta f 2 dt, right. So, this is the expression for delta p tie 1 2, right. Similarly, so I am clearing this one, right. Similarly, so I write delta p tie 1 2 then is equal to 2 pi T 1 2, right, and in bracket integral of del f 1 dt minus integral of del f 2 dt, right. Similarly, if we write delta p tie 2 1 is equal to, it will be same thing 2 pi T 1 2 by 2 to 1, sorry, 2 pi T 2 1 T 2 1, and here it will be delta 2 minus delta delta 1. So, first one will be delta f 2 dt minus integral of delta f1 dt, right. Now, these two equation you divide one after, therefore, we can write delta p ti 1 2 divided by delta p ti 2 1 is equal to, right, only if you look into that, it will be minus t 1 2 divided by t 2 1, because 2 pi will be cancelled, this will be cancelled, you take minus common, it will be delta f 1 minus integral of delta f 1 dt minus integral of delta f 2 dt. So, it will become minus t 1 2 upon t 2 1, right. Now, we know that t 1 2 is equal to v 1 v 2, right, by x 1 2 then p r 1 and cosine delta 1 0 minus delta 2 0. Similarly, t 2 1 is equal to v 1 v 2, it is 1 2, right, v 1 v 2 divided by your x 1 2 p r 2 then cosine delta 2 0 minus delta 1 0. Cosine delta 1 0 minus delta 2 0 same is equal to cosine delta 2 0 minus delta 1 0, because cos your minus theta is equal to cos theta. Now, if you divide this t 1 2, if you divide this t 1 2 by t 2 1, then what you will get, right. So, it is t 1 2 divided by your t 2 1. So, if you divide it, then it will be actually p r 2 by p r 1. So, t 1 2 by t 2 1 is equal to p r 2 upon p r 1, right. That means this one it will be actually this one, it will be minus of p r 2 by p r 1, right. So, this is your what you call that your expression for ratio of this, although in real unit delta p ti 1 to delta p ti 2 1 same, but in per unit it is something different, right, it is coming that way. Now, you define A12, that is we call area capacity ratio. A12 is equal to, you define PR1 by PR2, right. Therefore, PR2 by PR1 will be 1 upon A12. So, here it will be actually minus 1 upon A12. So, that means you can write that delta p ti 1 2 divided by delta p ti 2 1 is equal to minus 1 upon A12, right. That means, your delta p ti 2 1 is equal to sorry, it is 1 upon A12, because we have we have assumed that A12 is equal to minus PR1 by PR2, not PR1 by PR2. You assume A12 is equal to minus PR1 upon PR2. That means, 1 upon A12 will be is equal to minus your what you call that is your 1 upon A12 is equal to minus of your PR2 upon PR1, right. So, that is why it is 1 upon A12, but this one we define as a capacity ratio, area capacity ratio, but with a minus sign, right. You can take other way also, no problem, as long as block diagram concept is correct, no problem, right. Therefore, delta p ti 2 1 will be A12 into delta p ti 1 2, right. But note that it is in per unit, but in real unit your delta p ti 1 2 and delta p ti 2 1 they are same, but in per unit this thing has to be changed, right, because of if both the areas rated capacity is same, then delta p ti 2 1 is equal to minus of delta p ti 1 2, right. Right, otherwise this per unit thing, this area capacity ratio you have to multiply it, this one delta p ti 2 1 is equal to A12 this thing. So, our A12 actually minus PR1 upon PR2, right. Thank you very much, we will be back again.